This is the world's very first web page, which went live on August 6, 1991. A site dedicated to the information on the World Wide Web. The name of the site, info.cern.ch. A computer scientist named Tim Berners-Lee was looking to solve a problem. See, before the early 90s, access to information from other computers wasn't as easy. Typically, different information was stored on different computers, making collaboration difficult. Back then, Tim Berners-Lee, while working at CERN in Switzerland, wanted a better way to share documents and collab with other scientists who are working on research. In fact, what you're seeing right now is Tim's 1989 proposal and vision for what would become the web. This proposal of what would become the World Wide Web was developed on a NIX computer, you know, the one that Steve Jobs built on his side quest. And after a series of academic and research adoption, the project was made open and released to the public outside of CERN in the early 90s. This was the beginning of the World Wide Web, or the web for short. Anyone can use it for free without paying a fee or asking for permission. In fact, you may be old enough to remember ancient relics of sites that look just like this. A bunch of read-only static sites linked together by hyperlinks. This typically required a developer to manually edit the site if they wanted to add any new content. This era of the web was known as Web 1.0, or Web 1 for short. Web 1 in its infancy had great potential. Developers and hobbyists alike built and hosted their own websites, as well as web entrepreneurs who also recognized the potential in those early days. Now over time, these static Web 1 pages have evolved into today's dynamic Web 2.0 sites or platforms, where users can watch other users' generated content, for example, YouTube. But now, the general consensus is we're moving into a new evolution of the web, being termed Web 3.0, or Web3 for short. With Web3 having the vision of a decentralized and secure web based on the blockchain. But what is Web3 exactly? This video aims to outline the key concepts behind Web3 from a developer's perspective, and we'll use these fundamentals and technologies for other upcoming projects on this channel and beyond. In fact, the latest project is a decentralized social media application where users can tip ETH, upvote, and more, all running on the blockchain. Think of it like Reddit, but on Web3. This video is structured where we'll start from the evolution of the web to the new web era being termed Web3. We'll also cover what are DApps, DApp architecture, ERC20 tokens, NFTs, and how data is stored on the blockchain. And the results may surprise you, finally ending with some valid criticisms and the current limitations of the blockchain. And for those interested in the programming of smart contracts with Solidity, we also cover how a simple smart contract is deployed to the blockchain. Hi, my name is Evan. Missed you guys. It's good seeing you again. This one's going to be a bit of a rabbit hole. Well, let's begin. The web. An informational hub home to many of the largest sites used by billions across the world. Access to information is at our fingertips. Many can self-educate, watch entertainment, or even earn a living through the web. But how did we even get here in the first place? And more importantly, what is Web3? As the name implies, the web eras have famously been categorized into 3 different iterations. Most technologies we typically use today are seen as Web 2.0, like YouTube. In order to get a better grasp of what Web3 is, let's take a deeper look at the early iterations of the web. As mentioned, Web 1.0 being the first iteration was a read-only web, meaning users was typically served a static page. You could not interact with the site apart from navigating around through a series of documents connected by hyperlinks. As a result, users were seen as the consumers of the content, whereby the creator was usually the developer or someone who had technical know-how of how to create the site. Now fast forward to around 2004. We now reach the dawn of Web 2.0. This is where we saw an adoption of websites providing user interactivity. Web 2 is known for the ability for users to interact with the web, and Web 2.0 refers to the current iteration and what most technologies we use daily operate on. Web 2.0 started off simply as a user being able to change the state of a simple website, and with further innovation, this led to the ordering of books, flight bookings with a back-end database. Now, although the term iteration is used, there is no set date where Web 1.0 moved to Web 2.0. It's more of a general consensus reached after the web hit some form of new innovation. And fast forward to the present time, and with the advancement of development tools and wider internet access, users can create content, order meals from apps, earn a living with the gig economy, and even freelance. Users can now be both the consumers and the creators. And knowledge hasn't been spread faster on information, allowing people to experience events in real time. However, over time, we have seen a degree of centralization of services, where a few corporations make up what we use every day, whereby in most cases you don't have control of your data or how it's stored. Additionally, certain business models operate on collecting your personal data in order for it to be sold to advertisers, meaning companies make money from your data without any return to the user. Now, the key takeaway here is Web 2.0 is heavy on the centralization of data. And this is what Web 3 tries to solve. So, this now leads us to the third iteration, Web 3.0. The biggest fundamental difference between Web 2 and Web 3 is decentralization. Web 3, however, being a loose term, refers to a decentralized and secure web that runs on the blockchain, where people can interact with data, exchange currencies, and information without the need of an unnecessary middleman, like a bank or a payment system. Ideally, you become the owner of your own digital goods. An example of a blockchain used in Web 3 is Ethereum. Now, Ethereum can be seen as a distributed network of computers, where all participants, known as nodes, have to agree on the same state of the data throughout the network. If you want to look into this in more detail, there's a great video I've linked below which gives you an in-depth view of how a blockchain works. But for now, all we need to know is what a blockchain is. And we can boil down the definition down to a continuous append-only database, that once data is stored on this database, it becomes nearly impossible to change. Now, Web3 takes this fundamental technology of the blockchain to build applications on top of, that we can interact with, typically from a web interface. Now, you may be wondering, what does Web3 look like? Now, apart from using the blockchain to transfer cryptocurrencies, such as ETH or other tokens to another wallet, which sometimes means nervously checking your wallet multiple times hoping you send it to the right address, there are other use cases that can be built on the blockchain, similar to the apps that we have on our phone that provide a utility. In Web3, developers can build applications with the same utility running on blockchains, like Ethereum for example. And these apps that are running on the blockchain are known as decentralized apps, or DApps for short. An example of a DApp is Uniswap, which is a decentralized crypto exchange. But it can expand into more categories, such as digital art and gaming. And here's the definition of a DApp taken from ethereum.org. A decentralized application, or a DApp, is an application built on a decentralized network that combines a smart contract and a front-end user interface. Okay, we now got this new term called smart contracts, but what does that actually mean? And how does these decentralized apps work? See, in Web 2.0, when a developer builds a web application, say for example, we want to build a social media clone of Reddit. This usually makes up of a front end and a back end, where the front end would be where the user interacts with, and the back end will be where the data is stored in some database, data such as the user's karma, upvote, and post history. Languages such as Python or JavaScript's Node.js, being a runtime environment, will be the backend logic that interacts with our database. Finally, this web architecture allows the user to interact with their data through the front end. Usually, web applications like this are stored on centralized services, like a cloud provider, for example, AWS. This typically means that data is owned and managed by the developer or the company. And by definition, this app is centralized. With Web3, a DApp is slightly different, which focuses on decentralization. So how does this look for a decentralized app? Well, let's take the Ethereum blockchain for example. The front end can remain the same with one major difference. Rather than your backend being on a centralized cloud provider, your backend code is deployed to the blockchain, like Ethereum. The front end then interacts with the deployed code on the blockchain. Now, this code that helps us write this piece of logic is something called a smart contract, usually written in the Solidity language. The smart contract can be viewed as a piece of code that executes a piece of logic and lives on the blockchain. The important takeaway here is that a smart contract has the ability to store data, for example, what wallet address owns this specific token, or who was the last person to purchase this NFT. And this data that we can query from our smart contract is made available to our front end. We interact with the smart contract by deploying it on chain and getting the smart contract address. So unlike Web 2.0, when a centralized server goes down, there is an outage. With Web3 being a decentralized network, your application remains functional so far as the smart contract is always existing on the blockchain. The main difference with smart contracts is once data is stored on the blockchain, you can't modify this existing data or delete it. You can only add new data in the form of transactions to the chain, showing the transaction history available to everyone on the previous data that has been changed. And this form of design will work well for future applications that deals with finance and audits. So in summary, unlike Web 2.0 where servers are typically centralized, in Web 3.0 these decentralized apps are, well, decentralized. As a result, these decentralized apps being built on the back of a blockchain provide these following advantages.
Great, but how can we develop a decentralized app? Building a decentralized app requires a few different development tools. Earlier this year, I wrote an article that goes into more detail. You can check this out on smartbuilds.io, linked below. Now, there are different blockchains out there that we can build a decentralized app on. For now, we'll focus on building a decentralized app on the Ethereum blockchain. But the same concept more or less applies to other blockchains that support smart contracts. So just a summary from before. A decentralized app is pretty much an application which consists of a smart contract where data is stored and a front-end interface which we'll use to interact with the data. Well, let's break this down into what the development stack looks like.
Starting off with the front end, this is going to be in the form of a web application which can be built with standard web development tools such as React or Next.js. The backend, which you can think of as the smart contract deployed to the blockchain, is written in Solidity. Solidity is an object-oriented programming language used to write smart contracts. For the simplification of the development stack, we can think of the blockchain as an immutable database, where we can program what data to store on the blockchain through smart contracts. For example, the total supply of tokens issued by the smart contract, or even how many tokens of that total does Alice own. So how do we program a smart contract to store the data we want? Remix IDE is a popular-based browser compiler which can be used to deploy smart contracts to the Ethereum blockchain. To get a better understanding of smart contracts, we'll use Remix to demonstrate how a simple smart contract is deployed to the blockchain, where we can set a message stored on the blockchain and return the value of that same message. Similar to a generic class, a typical smart contract will be defined by the contract's name, with it containing its following functions. In this case, we have two functions,
a function to set the name of the variable message, and a getter function to return the current state of the message. Once we compile a smart contract, in the background, the contract is interpreted into bytecode, which is what the EVM understands. The compiler also produces an ABI, in which is used to understand the contract's makeup and function. Now that the smart contract has been compiled, to deploy the smart contract to the blockchain, we'll set an initial message value in the constructor, in this case being hello world. Notice how a log was created containing information on the newly deployed contract, information such as the newly created contract address and what wallet address deployed this smart contract. And once deployed, we can now interact with the smart contract on the blockchain. If we call getMessage, the variable we set initially on deployment is now returned, which is hello world. We can even decide to update the message state to a new message value. Since we're changing the state, this is seen as a transaction on the blockchain, as we're writing to the blockchain rather than simply reading off it. If we now call the same getMessage, we can see that the state of the message has now been updated to the new message subscribe. And looking at the logs, we can see a historic view of all the calls that interacted with the blockchain. Finally, and this is important for the completion of the DApp, we can use Ethereum-based JavaScript libraries such as Ethers.js to pull data from the blockchain into our web interface, which can be viewable by the user. So what we're pretty much doing overall is using the web interface to interact with or change the state of data stored on the blockchain.
And this is similar to how in Web 2.0 we have a website that interacts with a database, and as a user you can change the state of the data on the database, such as when you hit the like button. Was that smooth? No? Okay. So you now may be wondering, how do we connect our wallet to a decentralized app? How to connect a wallet to a DApp? How to write to the blockchain? Unlike Web 2.0, where users' credentials are stored on a centralized database, with Web 3, there isn't a need for a developer to collect the username or password. We can interact with decentralized apps through wallets. You may have seen other dApps show this in the form of a Connect Wallet button. But what is a wallet? Ideally, a wallet is a term to describe a medium that stores sets of private and public keys. You can think of it as a login account equivalent, but on the blockchain. It's what we use to sign transactions. And this is where wallets like MetaMask come in. Now, MetaMask is a browser extension / crypto wallet that allows users to connect to a decentralized app. Now, there are many wallet alternatives out there, but MetaMask is currently a popular wallet option. In MetaMask, when we connect our wallet, this gives us the opportunity to choose one of these public and private key sets that we can interact with a decentralized application. This is in the form of what MetaMask calls accounts. MetaMask handles the user's private keys, and say for example, we want to buy a token, the MetaMask window is invoked whenever we need to sign a transaction. By signing a transaction, this validates that the transaction came from a genuine public wallet address, known as the signer. Ideally, MetaMask gives us the ability to view and interact with a smart contract on the blockchain through our wallet. So, taking a real-world example of a decentralized application, how does this look from a developer's perspective? Take the project JoinSpace, which is a decentralized social media application, for example. MetaMask provides a documentation on how to connect your DApp to a MetaMask wallet. Ideally, MetaMask injects a global API into websites visited by the users at the window.ethereum object. Once a user has connected their MetaMask wallet, the DApp can interact with the global available Ethereum API, which we can pull information and create a profile. Your private key is used to sign a cryptographic hash to verify that it's indeed the public address that it claims to be. And this is why as a user or a wallet holder, it's important to keep your private key secure, as once a private key is compromised, anyone with access has full control over your wallet or your account or your funds. You can have a look into more documentation on how to connect your smart contract with Ethers.js and Hardhat. And if you're interested, let me know by dropping a comment below and we can cover blockchain development on the livestream development channel. Right, we've covered quite a bit. We've covered what a decentralized app is, or a DApp, how to build decentralized apps, and the Web3 DApp architecture. Now, the next part of this video is from a previous video from a few months ago. And if you've already seen this, feel free to skip this. Else, let's take a detour into the world of tokens and cryptocurrencies. Ah yes, ERC20 tokens, the technology standard behind your favorite projects. From stablecoins such as DAI to the meme traders FOMOing into the next 100x altcoin. As much press that surrounds ERC20 tokens, tokens can be a whole lot much more than the next dogcoin crypto project and can provide some genuine use cases. Well, let's begin. So speaking in general, what is a token? Well, let's start from the real world. In the real world, tokens can be in the form of winning an arcade game or spending a gift card or a company voucher. These real world tokens allow us to trade these points in to unlock benefits or purchase items. In the virtual world, it's more or less the same concept. A token can represent virtually anything on the blockchain that we can buy, earn, or trade with other people. Let's take Ethereum for example. A specific use case of tokens can be reputation points in an online game, or skills of a character in a game, or many more. Ideally, developers build these tokens with utility within their projects. An example would be Decentraland's native token, Mana, which users earn when buying and selling land, which leads to a new market where people can buy and sell and trade these tokens in the form of cryptocurrencies. But instead of every developer building their own token implementation, which would be quite chaotic, there needs to be some form of standardization, making it easier for others such as exchanges to list these tokens by building functions into the smart contract to transfer, withdraw, and swap these tokens. This is where the ERC20 standard comes in. ERC20, standing for Ethereum Request for Comments, is one of many standards native to Ethereum, where ERC20 is the token standard that helps keep track of fungible tokens. And by fungible, this means one token has the exact same properties as another token of the same type. For example, in the real world, a £1 coin is exactly equivalent to another £1 coin. And this £1 coin can be traded out for another £1 coin, both of the same value. Or 1 ETH is equivalent to another ETH. Meaning, if we make an ERC20 token named ABC, one ABC token is equal to all other ABC tokens. As a result, this makes ERC20 tokens an ideal medium of exchange. We can think of these as currency, where users can lend these tokens, stake these tokens, and even have voting rights. In order for a token to be called an ERC20 token, the smart contract which creates the token would need to comply with the ERC20 standard. But instead of creating an ERC20 token from scratch, a popular project out there is OpenZeppelin, which is a library that provides reusable templates for writing a smart contract that complies with the ERC20 standard. So, how does this look if we are to build our own ERC20 token? Oh, and by the way, seeing how a smart contract looks and how tokens are created may help you avoid potential scam coins in the future, but we'll talk more about that after. Well, let's begin. To create a token, we can use an online IDE like Remix to deploy our smart contracts to the blockchain, which is written in Solidity. The following shows a typical breakdown of an ERC20 smart contract. We can import the OpenZeppelin contract library at the top, where we can extend from it and change the name and symbol. This token name is going to be called Alphabet with the symbol ABC. And the number of tokens to be created would be 800 billion. Once deployed, Remix has the ability to call on these functions where we can see the token name as well as the symbol, and we can see the total supply of the tokens. being 800 billion. And all these tokens are sent to the address of the smart contract creator. These standardized functions finally make it easier for exchanges and users to easily transfer tokens, knowing that the tokens are standardized. And creating an ERC20 token can be done very easily, meaning technically anyone can create their own currency. And as many good projects as there are out there, with over 400,000 ERC token smart contracts that are deployed to Ethereum mainnet, some of these tokens are only designed to part you from your money. And if you're invested in crypto projects, there are tools out there such as Token Sniffer that help identify malicious contracts by providing helpful metrics about tokens and the likeness of possible rug pulls, but always look into doing your own research. With that said, ERC20 tokens have a lot of interesting use cases that are ever growing, from decentralized finance, where users can lend and earn interest, to the world of gaming and more. In fact, the latest project I'm working on is a Web3 decentralized social media app, which incorporates native payments, where users can tip ETH and earn tokens. The idea being users can earn tokens based on the content they post. Imagine Reddit on Web3, where the backend runs on a smart contract. There's no centralized server. So far, it's just a bunch of memes that have been posted and a freelancing forum. You can have a look at the project. It's called Join Space. We'll talk more about how it's built and how it works in future videos. You can find more details in the description below. Ah yes, we've now hit the crescendo of the current crypto craze. Welcome to the world of NFTs, where digital arts and collectibles are being immortalized on the blockchain. It wasn't too long ago when artists, celebrities and influencers alike were, and still are, purchasing digital arts for an eye-watering sum. However, NFTs do get a fair share of bad rep, and it's important to note that digital art is just one use case of an NFT. But what is an NFT? NFT stands for non-fungible tokens. Non-fungible means that the item in question is unique and can't be replaced. In the real world, an example of a non-fungible item would be a unique painting, like the Mona Lisa, where one original copy exists and it can't be replicated. Or it can be another non-fungible asset, such as land, where one piece of land has unique characteristics, like the terrain and the perceived value, or even the location. For example, a piece of land already owned can't be bought twice, or a piece of land in London would typically have a higher perceived value than a random plot somewhere in the Midlands. And this differs from a fungible asset like a coin, where we can easily swap out one for another, given that £1 coin has the same value as any other £1 coin. Now, NFTs take these characteristics and attributes associated with the real world into the digital world, meaning that NFTs, like digital art, retain these unique characteristics such as the rarity and other unique attributes. And compared to ERC20 tokens, which are fungible, NFTs are unique tokens that we can associate unique characteristics to it. We can see this in projects such as the Bored Ape Yacht Club, CryptoKitties, or even CryptoPunks. Now, it's important to note that NFTs is much more than just digital art. Because of its unique characteristics, practical use cases can expand to areas such as supply chain, concert tickets, or even inventory tracking, where we can monitor and validate that the goods are genuine and not counterfeit via the blockchain, and even real estate public records. So, how does NFTs work? There are different types of ways NFTs are represented on the blockchain. An example can literally be representing this image on chain, like Beeple's NFTs. However, the most common form of NFTs we see today make use of generating unique attributes in the form of rarities and traits, such as the background, the clothes, eyes, and mouth. So you may be wondering, how does digital art NFTs like Bored Ape or CryptoKitties work anyways? Let's take the Bored Apes for example. The Bored Ape project is a well-known example which has a max quantity of 10,000 artworks or token IDs. The Bored Ape NFTs are created with a combination of traits such as the fur, the eyes, the clothes, and the mouth.
These traits can be seen as base layers that are randomly combined to generate a unique graphic, with each NFT or token ID having its own rarity score. And depending on the rarity score, some of these apes are in more demand, thus increasing the perceived value based on open market dynamics. And you can get this ape for the bargain price of... And all of these apes have different rarity scores, making some of these apes more rarer than others. So you may be wondering, how does NFTs work with the blockchain? In general, NFTs are claims in a process called minting, whereby we send a crypto to a smart contract and we in return receive an NFT. Fireship has a great tutorial on how to mint NFTs, where he describes a smart contract as a vending machine. When an NFT is available, you can send crypto to that contract address, whereby a unique token is minted and transferred to your wallet. Like opening Pokemon cards, most cards are common, but there is a small chance that you can get a rare and valuable card. And by owning this NFT, what this really means is somewhere on the blockchain, there's a transaction linking your public wallet address to the NFT you've bought, whereby anyone can view and verify that you're the owner. Ideally, you own the receipt to this transaction, which can be seen as a certificate of ownership. But it doesn't just have to stop there with digital art. It can even be in the form of a proof of purchase for items instead of holding receipts. And similar to how we have a standard for fungible tokens named ERC20, these non-fungible tokens follow a standard known as ERC721, where the ERC721 standard ensures that each individual token is unique, transferable, and tracks ownership at the very minimum within the smart contract. And this is one of many standards. However, there are other NFT token standards such as the ERC1155, but we'll discuss that in other videos. Great, so you're now the proud owner of a digital art NFT, depending on how you view the whole concept. And the TLDR is, NFTs inherit unique properties, making each item unique. The scarcity of said item provides an intrinsic value based on supply and demand. But the next question you may be asking is, how is data stored on the blockchain? Now, this is where it gets interesting. Unlike the current Web 2.0 architecture, where we can store data on centralized databases, in Web3, storing data like images on the blockchain would not be practical, and in fact would be very expensive. As a result, when it comes to the blockchain, data is primarily stored on decentralized network storages like IPFS, where the smart contract holds information pointing to the address of where the image is stored. This is known as an off-chain storage solution, given that we're not directly storing the images on-chain. Let's take the Bored Ape for example. The original image along with its attributes and metadata are stored on some form of decentralized database. When stored, this provides us a hash, which is a reference to where this image is located. The hash of this image along with its metadata is stored on the Bored Ape smart contract, which we can then query the smart contract for that information. So what the smart contract is really doing is referencing where the image is stored along with its metadata and attributes. When a buyer purchases an NFT, the smart contract keeps track of the current owner's wallet address that owns the said Bored Ape NFT. And given that the image hash is stored on the blockchain, when a buyer purchases an NFT, the smart contract keeps track of the current owner's wallet address that owns the said Bored Ape NFT. So in the case of NFTs, the smart contract is pretty much acting as a ledger, which you can use to easily look up and verify who owns the said NFT, almost as a proof of ownership on the blockchain. But you may be wondering, what is IPFS? Or what is a decentralized storage? Although there are a few decentralized alternatives available, we'll be using IPFS for example. IPFS is a peer-to-peer network for storing and sharing data in a distributed file system, similar to like how BitTorrent works. When files are uploaded to IPFS, each file is split into smaller chunks that are cryptographically hashed, creating a unique fingerprint called the CID, also known as the content identifier. And this is what we get in return when we upload an image or data to IPFS, also known as the CID hash. The CID acts as a hash, which is a permanent record of the file. We can use it to resolve to get the image similar to a URL. Now typically this CID hash, or the address of the image, along with the metadata and attributes relating to the NFT, are stored on the smart contract. And in a nutshell, this is pretty much what the Bored Ape project is doing with their NFTs. So the key takeaway here is that images aren't typically stored on the blockchain. A reference to the metadata that includes the image hash of the images and the following attributes are. And the reason for this mainly is because that storing this data directly on the blockchain would be very expensive. So when you mint or purchase an NFT, the NFT represents a token that links to metadata that's typically stored off-chain on a decentralized database like IPFS. The NFT smart contract then stores the wallet address of the buyer as the owner of the given NFT, like a receipt verifying ownership, meaning you own the transaction. And this can provide potential benefit for industries such as counterfeits of goods, clothing, inventory checking, and even real estate, who can benefit from the immutable information that's stored on the blockchain, which is something we'll explore. And if you're curious what a decentralized URI looks like, here's an example of a decentralized IPFS link. It's the ETH logo that I uploaded to IPFS. You can view it in the description below. The current Web3 social media DApp, joinspace.xyz, incorporates IPFS, so you can upload your own images or mint your own NFTs. Now, in some cases, NFTs are being found to be using URLs pointing to centralized databases like Google Drive or cloud storages. The issue here is that anyone can replace the contents of the image after being sold, meaning you can receive an image that is totally different from what you bought. Or worse, a seller could simply just delete the image. As a result, you technically own the transaction that links to the NFT that doesn't exist. Now to note, although these technologies such as ERC20 NFTs are primarily used within digital art, the real-world applications of these technologies can spawn new industries such as counterfeit verification or supply inventory tracking via the blockchain. So Web3, DApps and blockchain technology. In general, we're still relatively in the early stages of Web3, at least from a developer's standpoint. And as interesting as this infrastructure provides, there are some limitations that would require to be addressed if blockchain technology is to underpin the web of tomorrow. Now this may be subjective, but firstly, the barrier of entry to understand wallets is a bit of a learning curve. And navigating the UI to confirm a transaction via a modal may lead to poor user experience. Secondly, there are currently hacks and scams and vulnerabilities that we're all too aware of. And lastly, blockchain's ability to scale as well as high gas fees. However, there are layer 2 solutions that help to solve this problem, as well as the upcoming ETH 2.0. With all these new technologies, it's always good to have a cautious optimism. And similar to the euphoric Web 1.0 and the sudden crash of the early .com bubble, it's easy to overestimate what tech can do in the short term and underestimate the potential it can have in the long term. And blockchain technology may be following this trajectory. Right, this video has already gone long enough, and if you're one of the 5 viewers still watching this, I would like to say a big thank you. This was a lot of information, primarily because this video aims to explain everything you need to know about Web3. Additionally, this video lays the foundation and theory for future blockchain related projects on this channel. Also, if you're interested in building decentralized apps, hit the like button and subscribe to this and the development channel. We'll be covering more. We've covered a lot, starting from the evolution of the web to DApp architecture, from wallets to ERC20 tokens, to NFTs, to even how data is stored on the blockchain. And this is pretty much the tip of the iceberg. And the best part is, there's a whole lot of interesting projects being built in this space as we speak. My name is Eben, thanks for watching, you stay awesome, Peace.